Warm greetings of the day. My name is Pranjal Sanjay Jambhale. I am a student of B Division, B4 batch. My roll number is 62 and my PRN is as follows. So today, I'm here to talk about power amplifiers. What are power amplifiers? Its type, its output, efficiency, application, its block diagram, and a trick at the end. So wait for it. Now let's start with it. Power amplifiers are electronic devices designed to increase the amplitude of a signal, voltage or current. In power amplifier, instead of common transistor, the power transistors are used. Power handling capacity of such amplifiers is very large and it is dissipated around power transistors. In power transistor, heat sinks are required. The size of power amplifier is very large and it is used in public address system and audio amplifier. Talking more about its application, they are crucial components in audio and radio frequency systems, where a small amount of input signal needs to be boosted in order for a higher power level signal to be given as the output. So here is the block diagram, as you can see, and an input signal goes inside the amplifier circuit, and an amplified signal comes up, is obtained. Now let's classify them on the basis of the position of Q point on DC load line. On the basis of the position of Q point, they can be divided into four types: Class A, Class B, Class AB, and Class C. Class AB is just a subtype of Class B. In Class A, the Q point is at the center of the DC load line. In Class B, the Q point is on the x axis. In Class AB, the Q point is above the x axis just below the center. And in Class C, Q point is below the x axis. You will be seeing the graph now. So now let's get into details. For Class A amplifier, the Q point position and input signal are selected such that the output signal is obtained for both the half cycles. So in A class amplifier, complete signal is amplified and it is reproduced at the output without distortion. Efficiency of Class A amplifier lies between 25 to 50%. In Class B amplifier, Q point and input signal are selected in such a manner that the output is obtained only for one half cycle. Q point is shifted to x axis as the transistor remains active only in positive half cycle. Negative half cycle, transistor enters the cutoff region and collector current flows only for 180-degree input cycle. The output obtained is only one half cycle, which is distorted. The efficiency of Class B amplifier is up to 78.5%. Now, a subtype of B class amplifier is push pull Class B power amplifier. In Class C amplifier, the transistor remains active only for less than half a cycle. For remaining cycle, transistor remains in cutoff region where no output signal is produced. Also, the signal is highly distorted. In Class C, collector current flows for less than 180 degree of input cycle. Efficiency of Class C is highest, but the output is most distorted. Hence, Class C amplifier is never used for audio amplifiers, but they are used in tune circuit required for communication purposes. Now is the trick that I was talking about. In this, since it can be a bit of tedious task to remember all this, let's put all the data in a tabular form and fill it along with me. The first parameter that we will be considering is angle of conduction. Angle of conduction specifies the duration or angle measured in degrees for which the active device follows the flow of current. This angle is crucial for determining the efficiency and distortion characteristics of an amplifier. In Class A amplifier, it is 360, as the input signal is such that the output current will flow for the entire cycle of the input current. We can say the angle of conduction in Class A is 360 degree. For Class B, the output current will flow only for half cycle of input signal. So the angle is 180 degree. In the case of Class AB, output current will flow more than B but less than A. So we can say it is more than 180 and less than 360. In the case of class C, it is very less, that is less than 180 degrees. The next parameter is efficiency. Efficiency is how efficiently it will take the DC power and convert it into useful AC power. For class A, the efficiency is about 25 to 50%. For class B, it goes up to 78.5%. Some Since it is a subtype of B and it is just some modifications made in B class amplifier, the efficiency remains almost the same. And in case C, the efficiency is maximum 90%. Next parameter is the position of Q point. Q point is also known as operating point. In the case of A class amplifier, it is exactly at the center of the DC load line. In the case of class B amplifier, it is on the x-axis, as you can see I've made it on the in the graph. In the case of AB, it is above the x-axis, just below the center. And in the case of C class amplifier, it is below the x-axis. Considering distortion as our next parameter, distortion is when the output is different from the input signal, then it is called as distortion. In the case of class A amplifier, there's minimum or no distortion. In class B and B, the distortion is more than class A and class AB, but it is less than C. In the case of class AB, it is less than B and C, but it is more than class A. In the case of class C, the distortion is maximum. Now, considering the applications, they each have their own applications. Class A can be used as outdoor musical system. Class B can be used as audio amplifier. Class AB can be used as RF amplifier, that is radio frequency amplifier. And Class C can be used as audio power amplifier. For references, I used a site. I used Canva to make the PPT. I also referred to the notes that were given in class, and I used Clipchamp for recording purposes. I would like to thank our ECA teacher, Mr. Aniket Kimballkar, to give us such an assignment which helped us revise our concepts on the given topic. So, thank you so much for staying till the very end. This was Pranjal Jambhale of B4 Batch. Thank you and have a great day.